Good morning. Good morning. Man, I was impressed. I thought 9:30 was going to be silence.
Well, you'd hope so, wouldn't you? You hope they went out last night and completely hammered, and this morning they're just like going through the motion, right?
Well, I was hoping, but anyway.
No, well, you were hoping, right?
Okay, so today, this morning, we're going to talk about unit testing, but not just generally, how you do TDD and stuff like that, but TDD is fantastic as a way to build stuff, I think, I do it on a regular basis, but the problem is, you don't always choose where you start from. And we've got a product we built, and it was one of those things, someone says, can you do me a prototype? And then the prototype mysteriously becomes the product. It was one of those. So we had about 6 hours to build this, in reality.
Jeez, yeah? That's a little over-egg, isn't it?
Oh, no, we built at a conference when we were speaking.
Yeah, all right, okay.
So we built this thing, that's it. We just threw the thing together thinking, we'll throw this away and build it properly afterwards, and it just became the product. So legacy code comes from the most surprising sources. The prototype you didn't believe you were going to have to do came to production. So it's very easy to end up with code bases that you didn't think you were going to be using unit testing in, or you built them without knowing that, sort of thinking at the time you didn't realize that unit testing was something you should be doing. Or it may be, they are really, they've been around for a long time, and it's all like the developers shifted, grown, and you just haven't got tests in place. So what we're going to talk about really is, based on that, and you think this is not going away anytime soon, this code base, how do I start introducing unit tests into this infrastructure to get the sort of things that unit testing gives me, the ability to evolve the product knowing I haven't busted a whole bunch of existing functionality and that kind of thing. So I'm Richard Blewett.
I was going to say, which point are you going
to... rambling on, yeah. So this is Andy Clymer.
No.
He's my code monkey for the day.
Not for the day, for an hour and a half. That's all you booked for, right? Yeah.
And he's going to be doing the typing, trying to derail the demos and various other sorts of things.
No clicking involved today.
I've got really sharp installed this time.
Oh, excellent.
So what we're going to talk about. So we're going to talk about why is there an issue around introducing unit test legacy code, and then really we'll look at a number of different ways of how you can start the process of introducing tests, which is, as we'll see, is a non-trivial sort of exercise. And then at the end we'll look at a way of introducing tests without disturbing the code base, which is, requires certain tooling, as we'll see. Okay, so typically with legacy code, it wasn't written to be testable. Okay? Well, obviously, it is written to be testable. You can leave now because you can do tests, but generally it's not. And it turns out that you can't just write code and assume you can test it. Generally, if you write code without testing in mind, you write code that isn't testable, or at least testable easily. So you've got this big code base that isn't inherently testable. There are dependencies between components that are hardwired. You can't break them very easily. So I can't run my website without being able to talk to the database. So my controller class requires direct access. It's got entity frameworks I've embedded in because I chose the solution from the project type that said I want a controller with entity framework inside it because that sounded like an easy way to get started. And so I've got this stuff all over my code that says if I touch anything, the database has to be there. Okay? So the very hardwired dependencies. Okay, do at the start. So I've got a singleton. So there's only one of these things because I only ever need one an authentication service. So I have one instance. The problem is I have one instance, and that is talking to the real database to do authentication, or talking to Google or Facebook or something to authentication. Then how do I unit test it without that infrastructure being there? And again, statics are a hardwired dependency. I have a type name and said, here is the method I'm calling. There's no way to rewire this easily. You'll see there are actually, turns out to be ways to do it. But generally, a hardwired dependency between types. So I've got these dependencies between things, this code that inherently I can't unit test without, I can't test. I say I can't unit test because I don't need to talk databases. So even if I could test it, that's not a unit test. But I have a dependency. So essentially, I have external dependencies, which, unless I break this somehow, always have to be there whenever I run this any test against the system. I'm inherently doing integration testing, but also frequently I need a user sitting there pressing buttons and that sort of thing to test the majority of my code. Okay. So the fundamental problem is, where do I therefore start if I want to introduce tests? So if code is inherently unit testable,
Do you not have your mic on?
I'm just wondering.
Yeah.
Am I mic'd? Am I mic'd? Which one is it? I've got two sayings and no feedback. That one.
Talk among yourselves.
Okay. Oh, actually, yeah, I can hear that now. Hey, man, that's like it's a big silence from someone talking at the front with no audio. Okay, so I've got a whole bunch of code that's not inherently testable. And the problem is, to make it testable, therefore, I need to change it in some way. The problem is, how do I know I haven't broken things? The only way I know I haven't broken things is by having some tests that don't fail. But then to introduce the tests, I also need to change the code. But if I change the code, I don't know. So you have this sort of circle of hell, essentially, about how on earth do I start? Because every single thing I need to do to make things testable is going to mean me taking risks to break stuff that already works. And I don't know. Users, sort of stakeholders, aren't generally very happy if you break existing functionality, because you're doing something, as far as they're concerned, is comparatively unproductive. I'm introducing tests. Why? It's working. No, I'm introducing tests. I'm breaking everything. This doesn't go down well. So, how do we start? How do we safely approach this problem? So typically, you will have, with legacy systems, which have evolved over time, you'll have code bases which have generally large, otherwise, sort of, why is this something a problem to tackle in the first places? We'll have lots of classes, and more worrying, you'll have very few classes which are enormous, but you may have many classes. You have lots of lines of code. I said not built with someone thinking about how am I going to introduce testing into this later on. And hopefully there is something there in terms of automated testing. If you have at least automated integration tests, you do need the database set up in a certain way, or this web service has to be available, or whatever. Then at least if you have some level of automated testing, once you start introducing stuff to unit test, then you have some validation on broken things. So I guess you said, what was one of my unit test? What's different about a unit test compared to an integration test? Small. Smaller.
It doesn't depend on the environment.
Yeah. So we don't have an external dependency. Why is that important?
You don't have to install databases.
Yeah, I mean, partly one of the things as you get integration tests is they generally can't run concurrently because they need things set up in a particular way for a particular test run. And so obviously if one test needs a database set this way, another one needs it set another way, then there's a sort of conflict in terms of when they run, so they can't execute concurrently. And you have to have all this stuff to reset state between tests. What's another issue about them running against a database or against web
Testing
services?
against known conditions.
Yeah, I mean, you don't know at this point, sort of like, if somebody has changed something sort of like outside of what you're seeing, all your tests start failing, so there's sort of external dependencies outside of the development arena that you start being concerned about. Another thing is they're slow, comparatively. If you're talking to a web service or you're doing some kind of long-running processing, Andy, in your unit tests or your tests, so Andy wrote a bunch of tests that were unit tests at the time. How long do they take each one? About 20 seconds. You don't want to run this suite of tests at the end of each build. It's sitting there going, 3 minutes of tests running. So yeah, they have to run quickly because you want them to run all the time. Integration tests typically, because they're touching external resources, aren't fast. Okay. Not to say that integration tests aren't important, and I said if you haven't got unit testing, if you've got integration testing, that's a good starting point. But if you want to introduce unit tests which run fast, which are very focused, and prove the functionality of the system on the test, the actual unit, then integration tests aren't enough. As I said, if you've got them to start off with, it's a great place to be. So who has a suite of integration tests across their entire application they can run on a regular basis? Oh, you used to go, yes. Okay. People who had their hands up, do you have a big split of unit tests against other? I was going to say, like, otherwise you must believe if you have that as well, we're done. You know. So I guess I should also ask. So legacy code bases. Whose legacy code base is based in .NET? That's majority. Good. Java? So, are you going to put your hand up? I have massive legacy code bases there.
You had someone at the back, right at the back, who was hiding.
All right, it's okay. Java, it's okay. I wouldn't say free love. Okay, so how about C++? VB6. We haven't got VB6. Mainframe. So you've got big code.
Oh my god.
Ouch. Some of these things we're not going to be able to cover here because some of it's just. I'm really sorry for you. Is what I'm saying. Yeah. So legacy code obviously exists in a bunch of different arenas. So the first thing you should always know if you want to use unit testing is delete everything that isn't being used. Because there's no way at all. You want to start writing a whole bunch of testing functionality against functionality that isn't actually used. And you say, well, how do I know? And sometimes you don't. It's like all you've got is a code base. If you have tools like ReSharper, for example, will grey out all the code you're not currently using. Okay, that's a great thing because you can just go through and I can just delete this. Now I know you go, well, what if someone comes along and says, I needed that functionality? Well, who doesn't use a version control system? Actually, no one's going to put their hand up even if they.
No, I know.
Obviously, with a version control system, you can always get the bit you deleted. But the last thing you want to do is start writing a whole bunch of tests trying to warrant against functionality that no one actually uses. So delete stuff that isn't in use. Certainly delete stuff that's commented out. Yeah? If it's commented out, obviously, patently, no one's using this functionality. You want to get a view of the code that actually is required to be unit tested. So just get all the crap that's there out of the way. Sometimes you go, well, you know, if I've got a public member in an assembly on a public class, I don't know whether anyone's using that. Okay? They may or may not be using that in my solution. The only way I reliably know is by removing it. So fortunately, the compiler is your friend at this point. It will shout at you to say that this method doesn't exist. So even if there's stuff you go, this doesn't look like it's being used. I can't see why someone's using this. Just delete it and run the compiler. It will generally shout and say, you need this essentially. Okay? So remove as much as you can things that code that isn't in use. Because the last thing you want to do if you're writing tests for code that isn't actually required anymore. Okay. It can be tempting to say, I want to choose unit testing. So what I'm going to do is I'm going to make this entire class testable before I go any. As soon as you start changing code, you inevitably will start breaking other code. The more changes you make in one go, the more code that's affected. And I've seen situations where people say, well, we're going to do unit tests, and essentially they break their entire code base, which requires changing their entire code base. They have no unit tests at this point. And so essentially, the chances that the thing works the same way by the time they've refactored everything is very, very unlikely. Okay? So you have to try and initially minimize the point of change. And it's not simple. You have to do specific techniques to make things testable without changing other code. And as we'll see in a minute, generally, when you make things testable, the code has to change, and dependencies, unless you do something about it, are going to break. And so you have cascading levels of change. So, the velocity initially will be slow, and you have to accept this, that you will not immediately get massive levels of testing, but it's a process, and the more tests and the more infrastructure you have in place, and the more testable the code is designed to be, then the faster you can start introducing more tests. But it is initially a relatively low velocity exercise. Code coverage, yeah. So code coverage, obviously, in testing terms, is how much of the code is exercised when I run a test. Who uses code coverage as a metric? Do you have a stated goal of code coverage? No. Stuff can't be checked in without 80% code coverage. Okay. Some organisations, as long as we have 100% code coverage, life is good. It turns out it's really easy to write code that has 100% code coverage with absolutely ridiculously pointless tests. Okay? Code coverage on its own isn't a goal. It's a useful metric when you're introducing something to testing to legacy code, so you start to see how far you've gotten on that process and sort of how far something to go. You can start measuring, sort of the velocity you're starting to introduce tests in. But in of itself, getting large amounts of code coverage is comparatively easy and a relatively pointless exercise on its own. It's not a metric to be sort of enslaved to, as the slide says. So let's bring us some code, Andy. It's a project called
Got two open.
Greeting.
Which one? You got two open.
No, there's one called Greeting.
Okay.
Okay, this is a trivial class. Okay. Simply, we have a method on it called greet, takes a name, and it basically looks at the time of day and says good afternoon and good morning. Why isn't this unit testable? Okay, so obviously I don't control time. I could argue that I'd like to do it on time law or something like that. I don't. What's the other problem? Yeah, how do I verify this thing does what I want it to do? I can't see the output. Unless I'm sitting there somehow scanning the console window, I have no idea what's going on inside this class. So how do you introduce testing into something like this? And obviously this is a trivial example, but it highlights fundamentally sort of common issues. That you have either hardwired dependencies of things you can't control, or you can't see the outcome of what's actually taking place. So, there are two ways to approach this problem. One involves changing the code and one doesn't. We're going to start off changing the code, and then later on we'll look at how we can maybe start the process without changing the code. So the first thing I guess is, I think there's a testing project in there as well. Can you bring that up? Okay, so here's some tests. And we have a fundamental problem that initially I have no way to verify what's going on. Okay, so we'll solve that problem first. Can you run the test?
Is this the right Test Explorer?
Oh no, I thought you might just use ReSharper.
Oh, you got it installed today?
All works. Life is good. So, obviously be very wary of tests which pass first time. Doesn't necessarily mean anything. Here, obviously, we're not doing any assertion at all, so it's just pass. So, one thing, if you introduce a test and you don't know how to verify the outcome, what should you do? don't comment out a test. Yeah. So if you put a cert.inconclusive on there, then essentially you're saying, here is a test, I know it needs to be done, I just have no idea how to do this code. And it keeps shouting you the whole time, essentially saying, this needs to be resolved. If you don't put the test in, you remove the test or something like that, or then there's no highlight to say there's a job still to be done. So if you know, you've worked out the test needs to be done, you know what the test is, you don't have to verify the outcome, then using a cert.inconclusive is a very, very useful thing to do. Okay, but in this case, we actually want to do something meaningful here to try and test it. So we need to be able to see the outcome. So let's go back to the code, so the system of the test. So essentially we have to be able to see the output to the console, or at least what would be the output to the console. So there's a few ways to do this, but the fundamental issue is we need to have some form of abstraction so we can replace the console with something else that we can make visible. So whenever you're doing testing, abstraction is the key sort of concept you're trying to introduce. Because without abstraction, everything is hardwired, and you can have no visibility or control over the system under test unless you're going to change values in a database, you're going to set a web service up in some way. There's no way to isolate the unit. So, can you create me an interface, do it inside the same class, visibility, interface called iOutput service. And just have a method on it called output. Okay. Can you take a string, which is the format, and an object array, which is the arguments. Okay, now, if we base output on the abstraction rather than the console, we have the ability to be able to plug something else in here that actually does output, or at least makes the output visible to us. So, the problem is, how do we get this in here? Yeah, we basically now have an abstraction, and we want to base this onto somewhere how the abstraction has to be provided. So inevitably, with testing, we have to be able to inject dependencies. Yeah? So dependency injection is all part and parcel of this mechanism. So, can you create a constructor that takes my output service? Okay. And, okay, so now we've basically got this abstraction. Then we can use this, so we can go to our here and do output service or output. You do know about the clipboard, yeah?
Ah, that's just for wimps, right?
Okay. Okay, so now, in theory the functionality should be the same, but we're based on abstraction, which means in the test we can provide an alternate version. I guess we should make the thing work as it did previously. So go back to the code. Obviously, one of the ways you want to output to keep the functionality is by the console. So let's make sure we have a console version of the output service. Let's simply just console write line. Now we have the same functionality available. What's the problem now with all the code that uses the greeter? It's all busted now, yeah? Nothing's going to compile anymore. So, although introducing abstraction is important, there is something more we need to do if we're not going to have cascading changes and suddenly we're having to essentially have wide-ranging sort of change, which means we're changing all the code, we don't have any tests, we're going to break existing functionality. So, as well as coding to abstraction, especially legacy code, we have to maintain the public interface into the code. If we don't, then again we get cascading issues. So, we're going to create another constructor, but this time we're just going to hand off to the other and just basically pass in the concrete implementation. So all the existing code will carry on running exactly as it did before, but now we've enabled ourselves to inject an alternate version. Okay? So now we can go to the test code. Test code, not test codes.
Yeah, I thought you said test code.
So what we need is an alternate version of the output service. So can you give me I'm going to write a test double. Test double sort of, they look like the real thing. There's a version that's there for testing. We can use something known as a spy. Spies allow you to essentially see what was passed into the system under test. Also be a dependency by the system under test. So essentially what we're going to do is we essentially want to see what the format string looks like.
I just want the format string.
Oh yeah, that's how it's string of format string. So essentially we're going to put the format in the args. We'll see what was actually been sent off to the, what's been passed off to the console at this point. So now, can you create an instance of that before, no, not directly, if we want to examine it yet beforehand? So essentially we have the NSA, which is an output service spy, and we pass that in, and now we can go and look at what the NSA is doing. Pretty much. Okay, so R equal. So actually you do string assert.
Oh, okay. So you want to do what?
String assert. Dot contains. Obviously we use MS test. See that now? We're using the end unit here, aren't we?
Mm.
More power. Contains. Actually, no. I'm checking this. It's good morning, so I just put morning in there.
It's not good or bad.
Yeah. Well, you want to make sure it's saying good morning or good afternoon here. Yeah. Okay, so now we should be able to run the test, and hopefully that won't pass because it has to be morning.
Did I run the test? I think I did.
Okay, so that now passes. We're verifying the outcome. So that's good. Now, can you go to basically copy that code and put it into the afternoon one?
You want to change that to afternoon, yeah?
Yeah. Just comment out the code above.
Which bit of code? Oh, this bit.
Yeah. So now we have a fundamental problem. We have two tests, which in theory both could pass, just they won't pass at the same time, unless we happen to be running this around noon. If we can run it at noon, we time things perfectly, life is good. Unfortunately, generally, you like to run unit tests off the end of a build, and saying, oh, we'll only build around noon isn't really feasible. So we need some way now of,
No?
Yeah, so, yeah.
Just a thought.
Or I guess your datetime.now equals, we can change the time. Or we could go to the system clock, we could change the system clock. But we need some way of affecting what the system on the test thinks of as time. And so, can you go back to the code?
Which bit of code?
Sorry, this is on the test. So we can now examine the output. Now what we're going to do is take control of what time means. Okay? So, again, we need an abstraction around this hardware dependency. We're in .NET in this case, so it's actually very straightforward to do. Because as well as being able to use interfaces, we can also use delegates. Yeah? So a delegate is another way of essentially injecting a dependency. Now, before we do that though, notice obviously we're trying to code to abstraction. We're coding to abstraction. The system and the test really should be based on some kind of abstraction. So can you go to basically extract an interface from the greeter? Is anyone using this in reality should be using the abstraction now, rather than the concrete class, because we're trying to break dependencies. Okay? So anything using this should all be testable and allow me to plug a different version of the greeter in.
Why isn't it giving me extract interface?
Refactor.
Yeah, I need that. Thank you.
Extract interface.
And this is Visual Studio interface.
Yeah, it has a Greek method on it.
You think?
Okay, so hopefully, obviously the test code is running against the concrete class, but anybody else really should be refactored to use the abstraction at this point. Doesn't necessarily mean that all they have to do is change the type of any variable they're using to put, in this case, an I in front of it. Yeah? It's not a dangerous sort of change to make at this point. But what it does do, it allows us some more flexibility. So let's go to the back to the greeter class. We need to take control of time. So can you create me another version of greet? And this time what we're going to do is, as well as passing the name, we're going to also pass in a delegate which will provide the current time. So bucket date time and called, I don't know, time provider or something. And now what we're going to do, we're going to ask the time provider, so take the body of the other Greek method, and instead of doing datetime now, we're just going to ask the time provider what the time is. Okay. So, inside the main method, what we do is we hand off the other Greek method, but this time instead of the time provider, we just pass in datetime.now.
Oops, sorry.
The important thing here, because we've now coded into abstraction in terms of iGreeter, the only code that should ever see the concrete class is stuff that is a test code. No one else should be actually using the concrete class directly. They should all be coding through abstraction. So the fact we have this other Greek method which takes the time is irrelevant to the other code. Because creating new methods on, you're polluting the time. But again, coding to abstraction, the only stuff that should code directly against the concrete class is test code. And so if we have extra methods on there that are there to aid testing, to aid test visibility, then that isn't actually an issue because the actual code people are using doesn't see those stuff because they're coding to the abstraction. You could say, what if people don't? What if people use a concrete class? Code visibility is not a security measure, okay? It's a way of defining an API. I always have reflection available to me. If I really want to go around calling private members and stuff, I can quite happily by reflection, unless I'm running in some sort of partial trust environment or something. So, in many situations, creating tests for stuff is generally hard, and you have to provide functionality that services a testable sort of interface. As long as that isn't actually on the abstraction that people are coding to, personally, I don't think that's a problem. Okay? But, I know some people get very upset introducing methods onto the class that are there purely for testing. But in reality, in most cases, somewhere down the line, you're going to have to do it if you truly want your code to be testable. Okay, so now, in the system on the test, what we can do, we can inject a version of what we think date time is.
Okay. So both, you want to change both of these?
Yes, so go into each of them and pass in a date time, which is for the first one morning and the second one afternoon. New date time.
Yeah. And then hour, this is the morning one? Yeah.
Oh, this is the morning one, yeah.
Is that enough? Yeah, got it. Yeah. And you want to do the same for?
Yeah, no, it's got that, no. 3 o'clock or something there. Obviously, in theory, we could have passed this into the constructor as well. The point of injection isn't the critical thing here. Okay. So now, in theory, both tests should pass. So go and run at the class level. Okay. So, if you're going to introduce tests into legacy code, you are going to have to change the code. In most cases, as I said, we'll see there are ways of dealing with this without changing the code, but changing the code generally makes it more flexible as well. So we now have code that essentially we have some flexibility in because it's not tied to particular forms of output, it's not tied to how we determine date time, which allows the code to vary in different ways, not only for testing, but potentially sort of in the future as we require output into an HTML or something as well. Okay, let's go back to the slides. Okay, so we code to abstraction. Abstraction allows us to put alternate versions in, but at this point, if we only code to abstraction and inject a dependency, we break everything. So, maintaining the public interface, particularly if you're talking about legacy code, is critical. If you don't, then again you get cascading changes throughout your code. More code has to change, the likelihood you don't break anything becomes higher. So, maintaining the public interface is critical. Okay, adding stuff into the public interface. Here we have some code that is calculating internal interest. If you're coding to abstraction, and the code using the system under test codes to abstraction, then you can just add extra members on, and the system and the code using this doesn't see them, but allows you the visibility of what's going on inside the system under test. Okay, yeah, so there's an argument that we should never do this because it pollutes the type. And again, the only coders should be using new to create things really, when you finish refactoring, is the test code. Everything else should in some way getting these dependencies injected. So they'll only see the abstraction, not the extra methods on the concrete class. Okay, now, there's another project there, so you can call order system or something like that? No, authorization. Okay, so what we have here is a bunch of code that has a dependency on some sort of LDAP server to do authentication. It doesn't have really a dependency on LDAP server, I'm pretending it does. But it basically has a dependency on LDAP server, does authentication, and then runs some rules about authorization. What we really care about is testing whether somebody is allowed to purchase something functionality. We're not trying to test whether authentication works in the LDAP server. I'm assuming that whoever wrote the LDAP server will check that sort of stuff. So what we really care about is making sure that the authorization rules that we determined here actually work for our logic. Okay, so we can see we have here a hardwired dependency onto the LDAP repository. We're also potentially going to do logging, but here we have a hardwired dependency onto what logging looks like. So for example, we may think it's important that when someone requests to authenticate, we log the fact that somebody has requested authentication. Maybe we need that sort of information for audit purposes. At this point, it becomes important to actually say, this is definitely happening. So at the moment though, unless I go and start scanning log files where it happens to be outputting, or I'm basically creating fake accounts inside my LDAP server, I really have no way to control what's going on. So, a long time ago, not that far, far away,
No. In a galaxy.
About 24 years ago, I was working on an account opening system for a bank. So it's a retail bank, and essentially you went into the branch, you said, here's my details, I'd like to open an account, and they had different forms of account at the time. And essentially, they had different sort of benefits and stuff like that. And if you were earning over a certain amount with a certain credit rating, they essentially try and upsell you to the account with more benefits, but also obviously higher fees and stuff like that. And if you didn't have sort of those requirements for the account you'd asked for, they tried and downsell to a sort of a low-level benefit and lower fees account. So we were basically trying to test all this logic and stuff like that. Now this was written on the client side was PC, it was talking to a mainframe. The mainframe as part of its functionality went off to a credit checking agency, it was not even or something. So anyway, the problem is when you're trying to test this functionality, you need a real credit score, because if you make up details, you get a 0 credit score and everything's always no, you can't have this account. Okay? So unfortunately, you only generally concretely know one person's details in the sort of level of detail that you need, and that's generally yourself. Okay, so the easiest way to test, sort of like, can I apply for this account and stuff like that, was to enter your own details in. Now, as part of the account opening process, goes off to the credit scoring agency. What happens to your credit score when you get credit scored? It goes down a bit. What do you think happens to your credit score when you get credit scored 30 times a day? It goes down very rapidly. The entire team wiped out their credit rating within about a month. So, being able to isolate the system, I mean, basically the bank had to go to the credit and say, can you purge all these people's credit details and restore them. But this is useful if you have a terrible credit score. Work for a bank that's likewise. So essentially, stuff that has external effects can not only be slow, but actually can have quite dramatic output. So even if all you're doing is saying, I want to make sure we don't hit real services which have external effects, like we're talking to a service which we have to pay for every time we hit. The last thing you want to do is run this on unit tests every time you build. Yeah. So we need a way of separating out dependencies. But in this case, the last thing you want to do is go and set up a whole bunch of test accounts inside your domain and have all the authentication details inside your tests. Yeah? Someone gets all your test code, they can authenticate in your domain to some form at this point. So the last one is actually hit real domain accounts. Okay, so we've got two issues there. One is the hardware dependencies, and we'll quickly refactor that in a minute. We can scroll down. So we've got purchase item, which is the thing we kind of care about. But purchasing the item has to go and talk to, so scroll down a little bit, scroll down.
Going down?
Yeah. Okay. So we go and talk to external services here to find out what margin we're making on this particular item, and then we're going to basically process the purchase of a certain item with a certain margin, a certain quantity. This stuff is going to have external effects. We do not want this to happen. Also, it may take some time. So we also have an asynchronous version of the code. Okay? So at least the calling code doesn't have to block. Let's try and deal with this one initially. How do we how do we test asynchronous code? Because inevitably, is anyone building Windows App Store style applications? Is anyone from Microsoft in the room? Just a useful thing to notice. No one. Okay, so these are applications that are meant not to block. And so inherently, you write lots of functionality asynchronously. If you're writing stuff asynchronously, how on earth do you test it? Okay. So this thing's returning a task. We need some way of writing a test that deals with the fact we have a task. So Andy, can you, first of all, let's just unhook the dependencies. So can you create an abstraction? There's a couple of other projects there. One which is LDAP. Can you go and create an abstraction? Could I use the repository in there? And so extract interface.
So this is So notice it doesn't give it. It says extract class here. That's weird, isn't it? I'm sure it used to say extract interface on Resharp. Oh. No, there's no option. Okay. Anyway, sorry. You want me to?
Extract interface.
Yeah. Yeah, I know. I'm just. What do you want to call it? Our user
repository. Yeah. So essentially, we're going to run wider dependencies here as well. We have exactly the same issue that we had with the greeter class, just maybe something more concrete here.
Yeah, done that.
Okay, and the class implements it. Okay, can you go back to the system under test, which is the order system? And even if we change nothing else, we have a free refactor at this point. We extract an interface. All we need to do is change this from our user repository, and at least we have a starting point. So we don't necessarily have to change the code at this point, but at least we now have an abstraction to work to, which allows us to start introducing tests over time. And can you do the same thing?
Did you build this before? Did you build this? You got some dependencies going on in between. Well, you've got projects with 4, 5. So
I did build it.
Do you think?
Yeah, I did. Yeah, say the one that's a Visual Studio 20.
So which was a new project?
So Order System is a 4.5 project. So I'm guessing the test project is getting upset because it has a dependency on that, but nothing else does. Yeah, do it 4.5. Who's using Visual Studio 2013?
Quite a lot.
Notice slightly flaky behaviour? Yeah, we've seen some strange stuff the last couple of weeks, haven't we? So, yeah, so sometimes not building something it should be, or coming up with strange build errors, you change project types and stuff like that. Okay, so order system now is based on an abstraction. You can do the same with logger. So go into logging direct, and just basically extracting the base called logger. Okay, the last thing, if you go back to the LDAP plot user repository, notice here, essentially, we take an iLogger. So can you change this to use an iLogger, and then do the same we did before, inject it, but create a second overload of the constructor which passes the concrete logger class in.
Yeah.
Again, try and maintain the public interface so anyone using this doesn't have to change their code, but we just allow ourselves to be able to test the code now. Okay, let's go back to the test code.
What, this down here, yeah?
Yeah, the actual test code.
Excuse me?
No.
Each time we create that override, supposing we knew that that construction was only used in a couple of places, is it better to create the override or change the clause if we know it's only a couple of clauses?
So, yeah, why go to the sort of like pain of change? The problem is about trying to isolate change. You say, well, okay, I know things in a couple of places. You don't change those places, but then you find that those changes have a knock-on effect to other code. You have to be pragmatic about it. If really it will have no other impact, then you can just go and change it at the source. But having no impact is a very brave statement to make. It's better to isolate where the change is really in a general case and make sure that you only are affecting changing the system of the test. Okay, so at this point we can plug stuff into the order system and check its functionality. But so. There are two issues here. Can you go back to the order system? It's doing a couple of different things here. One of them, is scroll down, look at the purchase item method. So first of all, it's logging. We need to make sure that it doesn't actually log, because it could be logging onto a remote server, not just logging to a local file. So this could be a lengthy operation, and it may be that the actual system we need to talk to isn't available, the test will break. So we want to isolate the log method. So scroll down. So a bit further to the bottom of the switch statement. Yeah, okay. So then we're talking to other external systems. Now we have a problem at this point. Now we could go and change this method, but in terms of what's going to happen when we hit this particular operation, maybe it's actually not that easy to just provide an abstraction and inject it. We need to have some other mechanism potentially of dealing with this. So one thing you can do, as well as extract interface, we can have a free refactor. We can also do extract method, which again internally is a free refactor. Yeah? So essentially we just basically take that piece of code, we move it somewhere else, and then so all we're doing is internally structuring the code. No dependencies have an issue, especially if we're using tooling to do it for us, and we trust the tooling, then it's a completely safe thing to do. Okay? So can you extract the method called to get margin?
So you want all that extracted?
Okay, so extract that. I don't know. Get margin internal or something. And if you scroll down a bit, we also go off to the accounting process. So again, this is about external effect. So can you just extract that as well?
What was it called?
I think it's.
Oh, get value, yeah? No.
No.
Process purchase.
Yeah, process purchase internal. Okay, no one external has been hurt by us doing this, yeah? So go to those two methods, and can you change them? If you make private static, can you make them protected virtual? So at this point, anyone using the class is not affected by any of these changes. What does it now allow us to do, though? Yeah, essentially, we can derive at this point, and we can replace those nasty methods of nasty bits of operation we couldn't do much about. We can replace them with stub versions. So can you go back to the test code and create me a stub order system class? So the stub order class basically gets rid of the external bits that we don't want to have to deal with in the system and the test. Those external calls aren't the thing we're testing. Yeah? So we can override, get internal, margin internal, and purchase item. And in this case, get margin internal will just return some value which is, I don't know, 0.1 or 0.5, yeah. And it's a double.
That's a double.
And then the purchase item returns void, so we'll just basically fake it out. Just remove that. Yeah, so at this point now, we have the stub order system has majority of the functionality in it that we care about testing, but it doesn't have the external dependencies. Okay? So the ability to take gnarly bits of code that are very hard to sort of decouple, extract them to a separate method, turn them into protected virtual, and then what you actually start running the test against is something that derives from the original and then replaces the stuff that's very hard to isolate. Okay? So there's a number of different approaches depending on what you're trying to deal with about how you remove external dependencies. It may be that we have a bunch of code that is a long-running sort of complex calculation that we know we do need to write tests for, but we don't want it to run for every single test we're doing. We want a simplified version for the majority of tests, whether it's a parallelized bunch of executable code. So what we do is for most of the tests, we stub that functionality out, and so we only execute it when it actually is important. That's the thing we're actually testing. Okay? Okay, so now what we can do is go back to, can we create a new test?
Yeah.
And so purchase item async. I want to test the asynchronous version here. Let's see. And just do admin user and product should purchase successfully. Yeah, same as before, below. So verifying the asynchronous version does the right thing. You go and grab the body of that up to the
body of this
the
one?
body of the actual test that we're doing, yeah?
Down to here, yeah? Or do
Yeah.
you want to take the whole
I'll
lot?
take the whole lot and then we'll amend it. Obviously we're calling these synchronous versions, so you test it, change it to purchase item async. And obviously the return type will be task event. So there's a bunch of different ways of dealing with this now. In this case, simply accessing the result. So you haven't got task.
Yeah, I'm going to task, it's right.
What's going to happen at this point in terms of the code? What's going to happen with the system on the test? Yeah, we block at this point. We access the result, and it's not ready, then we block. So if the task returns something, this is a relatively straightforward way to deal with it. But what we do if the task didn't return anything, but we want to verify that it finished. So it didn't return stuff, but it had other effects we wanted to test. Asynchronous result obviously is an option, so just return the task, or potentially we return void. So we need some other way of trying to verify outcome. So since .NET 4.5, what we've been able to do is, can you go to turn that into an int rather than a task of int, and use await. And mark the test as async. Okay, are you familiar with the async and await functionality introduced in C#5? So essentially it's me saying that when we get to this point, we haven't finished, but we can't continue until this thing finishes. So wire the rest of the functionality of the test after this thing completes. Okay? So you obviously have some result there, Andy, which I think is
yeah, sorry. I changed it back to order number, yeah.
Okay, so certainly that would work as a model. There's also, we could, if it was simply a task, you could wait on the task. The problem is if the task is long running, obviously we have an issue, but the goal is to make sure that this is a unit test, so it shouldn't be long running. That's why we're abstracting out and creating the stub version that doesn't talk to external systems, because we've got to make sure this runs in a reasonable amount of time. So, asynchronous stuff, there's a couple of different approaches. Sometimes you have asynchronous stuff that will run something and will fire an event later on, say, we're done. How on earth do you test that? That becomes very complex to test, because suddenly you've got this sort of event firing, and you can't get the test to wait on the event for what you can do, but you start having to create, I don't know, manual reset events, have stuff that's basically waits on the manual reset event, wire up the event handler, and this stuff you can end up with some nasty race conditions potentially in here, especially with sort of more than one asynchronous operation taking place. So, one of the things you can do is change the system under test. So even if it doesn't naturally export a task, is have another public member which essentially is a task. And that task is being completed when it fires the event. Okay? At that point, you now know you have a concrete sort of like relationship between sort of the calling code and the event firing to know it's completed. There's a type of task completion source. Can you just, inline here, just create me a task completion source, just so we can look at the API now. Task completion source, if we're trying to introduce testing to stuff that's inherently asynchronous, it's a very, very useful class. So, first of all, it has a property called task. So it exports something that, as far as the calling code, looks like a task. But also, if we do TCS, has a set result method. So at the point when you're finishing the asynchronous operation, you just call set result, and suddenly we now have something which is exposing something which represents the asynchronous work directly, rather than trying to sort of write a test that's trying to work out what the asynchronous stuff is happening. Okay? So task completion source is a very, very useful API for introducing unit tests into legacy stuff which is asynchronous to some degree. Let's go back to the slides.
You're getting close to half past.
Yeah. Go back to the slides.
Slides? Oh, jeez.
Okay, so asynchronous stuff, say, task completion source is your friend at this point. So we introduce a testable API to stuff that's inherently going to be very difficult to test because it has to be running asynchronously. If you have stubborn stuff in the middle, then extracting the method, making it virtual, allows you then to create a version of the class which doesn't have the nasty dependent code inside of it that you then run your test against. Okay? Well, actually, I've got a class which lots of the code is inherently like this. I want to basically be able to maintain the functionality of the class, but introduce a new, highly testable version of the functionality with disturbing nothing. So, what we can at this point do is extract the core infrastructure of the class into a separate class and essentially use the original class and adapt it into the new testable version. People familiar with the adapter pattern? Essentially we have an abstraction we want to use, we have a reality, and we write a class that bridges the gap between the two. Okay? What we can use is the original system. So I thought it was someone asking a question.
Nah, it's feedback.
It is. Okay, so in this situation, we've got, we can basically start creating this whole bunch of stuff that injects code in, and maybe to inject the sales service requires a whole bunch of complex wire up itself. So we don't want to sort of spend time trying to work out how that wire up is going to work directly inside the class. It's already been done externally. So we hollow out the existing functionality and just basically have the existing classes call out to our new product controller call. And at this point, it can call into nicely testable versions of the code that inject the sales service, inject the data provider. The original class doesn't change, essentially, in terms of external view at all. But now what we do, we just, in the actual class we're originally testing, we wire up our new testable version directly inside, and we just basically hand off to it internally. But we know all the interesting functionality now exists in product controller core, which is now testable, and we can write all the tests against product controller core, knowing we're not testing the product controller directly, but we know we're testing all the important functionality of the product controller, and that's written now in a highly testable way. Okay? So you're never going to be in a situation where I say I'm not going to change any code, but it's trying to find different ways of evolving the code without breaking all the downstream code along the way. Okay. So, I've got a whole bunch of code. I've got lots and lots of code here, and I think this stuff is so complex and so interwoven. I don't want to touch anything until I have some test in place. And at this point, you're in a very difficult place if you can't proceed without some fairly major tooling support. Okay? So there's two frameworks in the .NET world, at least the two I'm aware of, that allow you essentially to rewire existing functionality. Essentially, it either uses rewrite the IL of those functions or uses the profiling API behind the scenes. Okay? And the goal at this point is to, so when I call datetime.now, I'm not going to call the real functionality. I'm going to rewire where that points to so it calls the functionality I care about rather than somebody else's. Okay? Now, this isn't free. There's a cost you get. It's way slower than calling the actual method directly. Okay? But the important thing, it does allow you to get started without changing any code at all. Okay? So one of the tools that does this is part of the Microsoft Fakes library, part called shims, and also the paid-for version of TypeMock also allows you to essentially rewire static methods and concrete methods and stuff like that. Okay, so we're going to look at shims. As I said, TypeMock does a very similar job in the paid-for version, and there's similar things that exist in the Java world as well for rewiring sort of functionality that exists already. So this stuff came from, are people familiar with the Moles project? It was a Microsoft research project that essentially did this, allowing you to rewire stuff. And then they productized it, they removed Moles from Microsoft Research, and originally they only included it in the Ultimate Edition of Visual Studio. Who runs Ultimate Edition? 4 people. Who runs Premium? 3 times as many. Who uses Professional? Who uses Express?
Unfortunately, no one.
Unfortunately, no one. You want to get one project in each solution. Okay, so Microsoft Fakes originally was only in Ultimate, which means very, very few people used it. It's now, since update 3 of 2012, I think it was, they basically moved into Premium. So at least it's easier to get access to. Unfortunately, it's not professional. It would be nice if it was a professional, because this sort of stuff would be very useful generally, particularly if you have a legacy code base. But the idea is that I create a region of code within which I'm going to rewire what the meaning of a certain method is. Okay? And we do this by this thing called a shims context. So can you go back to our test library? Remember we had the other version of greeter, which we haven't changed. Cool, go to greeter.cs.
So when you said you installed ReSharper, you did literally just install ReSharper.
I did, yeah, just install it. You only wasn't installed, I installed it. It says, but go down. Okay, so we have another version which is understood or greeter slim, following the standard .NET framework.
Oh, this one. Okay.
Naming convention, that new versions have the word slim on them. Okay, so what we're going to do, we're going to try and test this method without changing it now. Okay. So obviously, we need to be able to examine what console write line looks like, and we need to be able to control what datetime.now does. Okay, so can you go back to the tests, copy the two tests, but instead of, or copy the class and call it test greeter slim. Yeah, so copy the whole text fixture.
Oh, great, you've got no keyboard mappings. Jeez.
Go on the web or
Yeah, whatever.
some browsing. Okay, so you need to add test fixture to it as well. Okay, so this time we're just going to use the original we're going to use the greeter slim class. So get rid of the NSA, get rid of the and just create a new greeter slim. And in the greet method, just pass in the string. Okay. And do the same in the afternoon test as well. So we're back where we were with the previous test. How on earth are we going to test this stuff? And what we're going to do now, rather than change the system under test, is change the meaning of the dependencies that it's going to be using. Obviously, this does require you to know the implementation. Yeah? If you don't know the implementation and what you're trying to rewire, then there's no way you'll be able to sort of select the right things. So the test ends up with a slightly sort of incestuous relationship with the actual system under test. Okay, so what we need first of all is to generate another class that kind of looks like the greeter for the system under test, or looks like, the dependencies for the system under test. So can you go to the project?
Which one?
The test project, and open up the references tab. And now, what we want to do is we want to rewire what datetime.now does. Okay, so right-click on System. Now, the datetime class is in MS Calling, but you never see MS Calling in the references because it's inherent that if you haven't got a reference to MS Calling, you ain't doing .NET basically. So we right-click and say Add Fakes Assembly. Okay, and what it does, it generates a new assembly. So, can you, around the greet call now, can do using shims context.create. No, you don't need to assign it to anything. Shims context.
Still using the old greeter as well.
Oh, thank you very much.
We could have watched him crash and burn, couldn't we?
Okay. So now what we're going to do, before we call greet, is we're going to rewire what datetime.now does. Yeah? So, can you do before we call greeter, can you do datetime shim, I think it's called? So, can you just bring that in? So I think it's shim datetime? Yeah. Okay, so we have this new class that's now available to us. It's been generated, we say add fakes assembly. Now you can do shim datetime dot. Now we want to change what the getter does of datetime.now. So you can do now. We have a now get. If we wanted to change the setter, we do now set, but
there is no set.
Now it doesn't have one. But essentially, we basically this thing is a data that returns a date time. So we can do whatever we want in this at this point and say this is the meaning of datetime.now. Stream close up. Okay, so yeah, it's basically a func of date time. So Andy, can you do equals? And what we do want to do is make date time now return an afternoon time. Okay, at this point now, we know we're now in control of what datetime.now does. Okay? The other thing we need to do is get some level of visibility about what's been sent to the console. So can you go to create a string outside of the using that we're going to do for our assertion in a minute. So yeah, spied output. Okay, and then we'll have a string assert on the afternoon, yeah, on spied output. Okay, so now we've got to do is somehow find out what was in the console at write line. So can you do shim console? See, here's the problem. It's create a date time, but MS calllib is huge. Yeah? If it created a new version of every single class in MS calllib just automatically, this would be a lot of code to generate. So I'm assuming it does date time because it's really useful for conference demos.
Yeah.
So you just do it automatically. So no one has to see the man behind the curtain sort of stuff, yeah? Okay, can you go back to go to the projects, and notice we've now got a fakes folder. Yeah? One for MS calllib and one for system. So if there are types we want to bring in, remember there's no reference to MS calllib. So if you say I want to fake out system, it automatically does MS calllib for you as well. Yeah. But we want to essentially say I want you to do the console class as well. Okay. So go into mscalllib.fakes because that's where the console class lives in MS calllib. And then what we can do is
open that up.
So yeah, I think it's open that up. And actually, no, it's not. It's not open that up. It's a separate. Yeah, the next line. And then, so essentially, we want to go to shim generation. Okay. And then yeah, it's and then here we want to add a type name system.console. So essentially we're saying, I want to shim out system.console in here, so please generate me the shim for this class as well. You can do it for whole namespaces as well, you can do it for completely assembly-wide, but generally, limit the amount of scope, because there's a lot of code gets generated behind the scenes over and over again. Okay, so compile that.
God, it's taking ages.
Right. Okay, so now go back to our test code. Okay, so now hopefully we can use shim.console. Okay, go back to the mscalllib.fakes. Can you do add full name rather than type name?
Yeah.
Okay, and compile that. I think type name you have to be explicit about everything about the type in assembly. Okay, but test code. Shim console? Now we've got shim console.
Magic.
Okay, so now the problem is that the console class has a lot of overloads for write line. And we've got to decide which one we're going to replace. Andy loves this.
This is
so
rubbish.
Do .w. WR. So we've got write line boolean, write line decimal, write line object, right. Now the problem is, we have to go to the code now, go back to the system on the test, agree now? And say, which overload is it using? Okay. Now,
Rubbish.
which overload is it using? There's a lot of them. It turns out in this case, because name is a string, there's an overload that takes two strings. Okay? Very commonly, there'll be overload that takes a string and an object array. But in this case, because name is a string, it's the console write line string.
You reckon? Oh, the compiler says no.
Compiler says no.
It says string and object at arg0.
Right? Pretty
I don't know. It could be wrong.
Oh, okay. Interesting test. Go to the test code. and do right line string. Oh, they're in the string. Oh, that would explain it. Okay, yeah, string object array. Oh, string object, yeah. It must be that one.
Yeah.
Okay, so as you can see, if it's got overloads, you have to work out which one it's going to be using. I mean, it might be wrong. It might be the object array it's going to be using. We'll find out. Okay, so what we're going to do is string right line, string object, and that again is a delegate now. Okay, so we're going to basically, it's a delegate. So equals, and then we have the two parameters, the string and the object.
Format and the parameter.
Args, whatever, yeah. Goes to, and can you just do spide output equals string of format f comma p. Okay. Let's run that test. What didn't work?
The test.
Oh, great.
Oh, this looks easy to solve now.
Yeah, this is one of those we'll solve this in a couple of minutes. Oh, okay.
You haven't run this in 2013 before, have you?
I haven't run this in 2013.
No, I thought you know.
So, why did I run it in 2013?
I don't know.
What's the chance of us being able to load it in 2012 and it will actually load and work? So, can you close 2013 and run 2012?
I'd have said nil personally, but hey.
I think it's pretty unlikely, but I prefer to be able to actually show this actually working.
You have 2012 here, yeah?
2012 's there, yeah.
You'll need to change the version in the solution.
Yeah, I think it was a 4.5.
When you created the ship, it was that all.
I know, it was version 4 in the shim, wasn't it? It said MS called it version 4.
Yeah, but MS Call it is version 4 anyway.
Oh, that's true. Yeah, yeah.
It-
Yeah, of course,
inline
yeah.
override of
Of
the,
course,
version
yeah.
installed.
But you're going with sharper in here, aren't you?
Of course, it's got to be sharper in here. You're not going to need it, but we do have to be sharp.
Oh, you do have a sharper. Close.
Okay, so just open the project.
Where do I find it?
It will be in C demos, DevWeek 2014, testing, routing, that one. Okay, let's try and run the test.
Well, let's just
Compile it.
let's do a clean build first, I reckon. Not looking good, dude.
Not looking good, is it?
Let's just dock this over here somewhere. Okay.
Okay, so can you try run that?
Jeez.
Can you try and run it? Sort of right click on the on your test. Exception on stack trace. This really isn't looking good, is it?
No. Other than that, it's really cool.
Yeah. So this is an awesome technology, which is very reliable.
Can I ask you to regenerate the fakes?
Yeah, maybe remove the fakes.
If you open it up, the test,
Which
on the left-hand side?
yeah, on the left-hand side, and you click on the actual test.
oh, we've got exactly the
Oh,
same.
it's the same problem.
I mean, I can remove it if you want. If we can, what do you want to remove that?
I don't know. I think.
Should we try it quick?
Yeah, try removing it and that one as well.
Have you used the correct version of console.writeline?
We use the-
Possibly we're using the wrong version, but it's just.
No, this area doesn't look like that, does
Yeah,
it?
it looks like it's the profiling API it's trying to use, and I'm pretty sure it's. Open up the references and go to system. Can you remove the system 400 effects? and then right click on system, and system,
Yeah.
do add fakes assembly.
Okay.
Okay.
And then you
So
want to
run
go.
compiler, which should generate the. Okay. So now try and run the test again.
We need to add console.
Yeah, but I think it's going to. I don't. Well, we can see. It was MMS Calling.
Oh yeah, sorry, yeah, we can see that there. Yeah, so I'm just going to fakes.
Screen real estate.
Yeah, so yeah, add in there shim generation.
Was it shim
Shim
generation?
generation, then add full name system.console. Okay, run that.
Right, I'm just not convinced because we didn't get any compilation errors. Feels a bit better.
Yeah, okay, so let's go and
Run the test.
run the test. Fingers crossed.
Maybe try running it in MS Test. I think it doesn't work in Resharp.
Oh, you're right. No, you're absolutely right. Okay, this is going to be fun. Okay, so go back to the test. You're right, Resharp doesn't like fakes.
Right, what do you want me to do? Test
Okay,
Explorer?
go to the test. And can you change it so it's using MS Test rather than Resharp, rather than NUnit?
You can run it from the test.
Well, no, I haven't got the plugin installed
Oh,
here, so it'd be quicker just to change this to the test class.
Jeez, every time.
That's method. Oh, it's missing the reference.
Well, I realise that, but I'm
Just
surprised.
add a unit test. Say right click on the project. Say add unit test, and it'll bring the and so it'll bring the right thing to it. Right. Test. God, it's been a test project. Okay, try that. Try adding it. You never know. You might bring the right. Yes. No.
That's a doodah.
That's an unit one.
You remember what the reference is?
Okay, I'm just thinking. I think.
You remember what the
Okay,
reference?
no, can you just go to the original test class and right click on one of the tests?
Wait, this one?
Yeah,
Yeah,
right click in there.
yeah.
Okay, I've got the plugin installed already in 2012. Okay, turn it back to the test fixture and test. Make that test. And say the other one test.
I didn't change it.
Yeah. Okay. So right click and do and run it in MS Test.
This one, right?
Yeah. So the run test at the top. So test. Windows Test Explorer.
Did that work?
Thank you. Okay. So is that the?
Is that the one? No, it's good afternoon, wasn't it?
Yeah, it was good afternoon. I think
I'm
it's
guessing
the
it's this one with the
You know,
180.
the one that's taking a bit more time to run? Yeah. That's basically the test we're running here. So we've rewired essentially. I mean, can you do the same for the morning one? Just so we have the same stuff. So just basically copy out the using block.
I just copied that a lot.
Yeah, it's gonna be helpful. And turn that into the morning. Okay, so hopefully that will also work. Again, we should see that it take a bit longer than other tests.
I haven't got it turned on, have you?
Yeah.
There you go.
Okay. Oh, that's fast.
Maybe it's the first one. Yeah, the first one is
Yeah,
the
the
thing.
first one has got a lot of work to do because it's got to rewrite put the profiling API in place. Okay. So the shims infrastructure allows us to replace existing code without dependencies without having to basically change the system under test. It's certainly not for free, there's a cost to it, test runs slower, and if you have lots and lots of shim-based tests, there's a big test bed, the test will take a reasonable amount of time to execute compared to if everything was sort of standard test and stubbed out and stuff like that. Better slides? Okay, so specifying, you basically wire a delegate onto whichever method you want to rewire, but you have to know exactly what the system under test is doing to know what you need to stub out. So therefore, there is a very high dependency between the test and the system under test in terms of its implementation. There's things you can do. I mean, this isn't just useful for legacy code, although that is really, I would argue, the primary place. There's always somewhere, when you're creating abstractions, somewhere you do have to eventually call the real API, okay? That does talk to the external world. How do you write tests for that stuff? Now, typically you tend to say, this is integration test time. One of the things you can do with Phase is you can essentially, for example, rewire the app settings and put your own sort of values in there to say, this is what happens when I talk to the config file. So you don't have to, even the code that talks directly to the config file, you don't have to write that as an integration test, you can write it as a unit test. So that kind of stuff also can be quite useful with the Phase libraries, testing the edge boundaries of the code. Okay? We've done statics, which are very commonly what you're trying to do because they're harder to replace. But you can do instance methods. If you have a hardwired dependency between instances, you can say, I want to shim out all instances, in this case of the open method, okay, which will do instance rather than static members. We can also shim different versions based on different instances. We can wire up how constructors behave. We can actually have a fair amount of control over exactly what ends up being executed. But there are issues. One is it's a bit slower, but probably the biggest issue is shims, and one that you don't notice until it bites you. That if your test framework runs tests in parallel, shims will not be your friend, okay? Because it rewires code on the app domain level. So unless you run each of your tests in a separate app domain, then every single test is going to collide over its rewiring of the selling methods, okay? Because obviously, we do not want this stuff to run forever with this rewiring. Just quick, go back to the code. Obviously, when we create a shims context, what we're saying in the using block is throw away my rewiring at this point, okay? Because obviously, you don't want the code generally to run with your custom version of daytime run now. You want it to run with the real version. So if two tests run concurrently, both rewiring this differently, the last one wins, essentially, okay? So be very careful of using this stuff when you have a test framework that does concurrent testing. Back to slides.
Got a question.
Okay.
Just thinking of some malicious ideas. Can you run it not in the shims context and then hack some third-party libraries that you have problems with?
No, you have to use a shims context. Without a shims context, it doesn't rewire anything. So you could have one big using block around in main.
That works.
Well, I'm not recommending it remotely.
We would never recommend malicious code, especially when being videoed.
Absolutely. Never do that sort of thing at all.
Ever.
In
Never.
any circumstance whatsoever. Okay, so sorry, go back. So certainly, it doesn't hang on currency. But the last thing is, I said, there's this team I was working with who, I sort of went up there and did a whole bunch of stuff around test-driven development, and then went away, and they phoned me about 2 years later saying, we're having some problems. Microsoft has just removed molds from Microsoft Research. We don't know how to make any of our tests work anymore. They've basically written their entire test infrastructure based on, essentially, shims, which means you don't have to think in terms of breaking dependencies when you write the code, which can be, it might be a very familiar way to write code, but generally, test-driven development forces you down a path of loose coupling, which is generally a good place to go in the first place. Shims, type mock, in terms of rewriting the IL using the profiling API, it's a really useful tool to have available to you, but you do not want to base your entire testing model on rewriting IAM and stuff like that. Okay. So it can kind of lead to quite lazy practice like, well, I don't need to decouple stuff, I'll just shim everything when I come to use it. And I said the coupling you end up between test and the actual implementation means you change the way something's implemented or your test break, even though the functionality is exactly the same, just happens to be calling a different version of an overload or something like that. As I said, this stuff is kind of still available in Java as well, so the PowerMock library also does something very similar. It basically rewrites the bytecode, and so next time it goes through compilations, you're running your new version. So Java has this type of stuff available. Generally, managed code has an easier time with this because it has this intermediate step before execution. But there are stuff in C++ as well. So Google Mocks as a library allows you to essentially mock out statics and stuff like that as well. So these things are available for other environments, not just .NET. So Java's probably a very obvious one it's available for, but said C++ does have some of this functionality available within it as well. Okay, so legacy code, it's fundamentally an issue because it was never designed to be testing, and so trying to introduce testing is a fairly fraught exercise. That you have to change the code in general to make it testable, but because you don't have any tests, changing the code in of itself is a very risky exercise. So everything is about isolating change, trying to make sure that when you change code to make it testable, it doesn't have cascading effects, so you end up having to change the entire code base to introduce unit testing to one part of it. So a number of different techniques we can use. Depending on your situation, you've got tools in your armory to be able to affect this, but the main thing is to try and minimize change and understanding it is not going to be something which happens overnight. It's an exercise which you gradually introduce tests into an infrastructure. The more tests you have, the more rapidly you can proceed because you can start receiving more confidence knowing that I have tests around this sort of area, so if I break anything, it will become obvious very quickly. But when you start, it's not going to be fast. Fortunately, things like shims can help you get around some of the more nasty bits of code that would be very painful to change, so you can, for certain tests, at least get some level of test coverage before you start tackling them. Shims will allow you to do that. Okay, so, any questions? I know I haven't told you how to do this in VB6, because I have no idea what VB6.
So your first example where you were testing the greetings class, you actually didn't test the greetings class, you tested the internal class or?
The greeting class.
Yeah,
I did test the greeting class. We had to change the greeting class to test it, but we did test the greeting
Yeah,
class.
but if the legacy code is using that method which is not tested, if somebody changes that method, there's no coverage to that.
Okay, yeah. We're not doing black box testing as in I have no idea what's going on. I'm deliberately changing the code to make it testable and understanding what I'm testing. That's absolutely true. That if someone decides to add a whole bunch of code into the greeting method or something like that, then I won't be testing that. But the idea is, I'm in control of the code here, so it's not something that, I'm just hoping I'm making some effects on. I know what's going on, I'm deliberately changing the code to make it so I can introduce tests on the functionality I know. But yes, you're absolutely right. If people put a whole load of code in the Greek method at this point, then that wouldn't have any coverage. Hopefully I'll be running some sort of code coverage tool and that will suddenly leap up that this isn't getting exercised. But you're absolutely right there. Yeah.
One way of also getting bringing code into a class maybe is to say a container with a bunch of interface classes. You had earlier on interest in that it used virtual methods and overrides. Do you have cases where you prefer to use one sort of class structure over another, or you choose to use one over another?
If I'm faced with a situation where I have lots of fairly unpleasant code using a lot of different types in the middle, but it's not like use many places in the class, generally, rather than injecting large numbers of things initially, I just extract that block of code because it's the least level of change. But I know eventually I'm going to go to the place where I'm going to be injecting stuff, but it's about how do I start, and it may be quicker to start by saying, okay, let's just remove that whole bunch of dependency within the middle of a method. And so if you have lots of dependencies, then rewiring everything immediately means you do make a lot of change on public signatures and stuff like that, which requires you to do a lot of work to fix that up. Whereas just extracting the method may be a low touch sort of in terms of impact. Okay, so demos and stuff like that will be available on rockstallknowledge.com. They'll also, I guess, probably appear on the DevWeek site when we get it all uploaded up there as well. Thank you for attending.